Okay, good morning, class. Today, the next lesson for class 12th, we are starting with chapter number 1, and the topic is the principle of superposition. Now, the principle of superposition says you that if a system have number of charges, that means these are the number of charges, Q2, Q1 and Q3 and Qn up till Qn, these are the number of charges, then the net force acting on them on any charge due to the other charges the vector sum of all the forces. That means if you want to find out the force on this charge q1, it is the vector sum of all the forces exerted by these number of charges. So we can say F equals to F is the force acting on charge q1 is given by the vector sum of F12. F12 means force exerted by charge q1 and q2, F13 and F this. So applying Coulomb's law, taking 1 upon this common, so we are getting this as a result. So this is the principle of superposition. Now moving further, let us revise the few things which we have already done. The intensity of electric field, we know that intensity of electric field, it means that when a charge is put inside the electric field, then what happens, it's experience of force, and that force is its experience of force, and the intensity or the electric field created by that force is given by F upon Q. So putting the value of this F, and we know that F equals to 1 upon 4 pi epsilon 0 q1 q2 upon r square. This is given by the Coulomb's law. So we have put the value. By putting the values, after calculating this, we are getting this, and we know that r cap equals to vector r upon r. So solving this, we are getting this as a result. About the dimension, we know the dimension of force, it is mlt minus 1. So we have put the value of mlt, put the dimension of force by putting the dimension of charge. So we get mlt minus 2. A means it is the dimension for current, A minus 1. So this is the dimension for electric field intensity. After this, few other topics related to the intensity of electric field. Now what we are doing, we are finding the intensity of electric field due to the continuous charge distribution, which means that we are having a long wire in which the charge are continuously distributed. So it is of three types. Number one, the one dimensional. One dimensional means linear charge, means we are finding the intensity on the long wire. Then we are having two dimension. Two dimension means we have to find out the intensity of electric field on a surface charge, means about on the area. Then we are having three dimension. Three dimension means we have to find out the electric intensity due to the continuous distribution of charge on the volume. So coming on the first topic, that is a linear charge distribution. Suppose we are having a long wire of length L. We have taken a small piece del L. We have taken a small piece del L. So we are finding the intensity of electric field. Then the intensity of electric field is given by F upon Q. So F upon Q means the value of F by Coulomb's law. We have put the value. So this we are getting as a result intensity. This is the intensity. Now this Q, we know that linear charge density, this lambda is a linear charge density, and linear charge density is given by Q upon L. And calculating the value of Q from here, we are getting Q equals to lambda L. Now for a small charge, that is dq equals to lambda upon dl. So this is the value of dq. So we have taken a small piece. We have taken a small piece of wire that is del L. So intensity we are finding out. So intensity on this is given by dE. So dE equals to 1 upon 4 pi epsilon 0 dq upon r square. Integrating this, on integrating dE we get E. On integrating this is constant, it comes out. And on integrating lambda dl, so we get lambda L. So this is the linear charge density. It is important for the numerical purpose. Numerical are simply based on this. He simply asks you to calculate the intensity due to the linear charge distribution. After this, we are having a surface charge density. Again, in the same way, surface density, that is sigma equals to S upon Q, where S is the surface and Q is the charge. So taking a small surface, this is the small surface, this is the surface, and we have taken a small part of this surface, that is del S, and del S is given by del S, and del Q is given by this sigma ds. This is the value of dq. Similarly, in the same way, we have put the value of q here. On solving it, we get this as a result. Again, this is important for your numerical purposes. Then coming to the volume charge density, in the same way, putting the value of dq here, in place of dq, we have to put this rho v. Rho is the volume charge density, and volume charge density is given by V upon Q. So V upon Q equals to 1 upon 4 pi. We have put the value of dq here. dq equals to this much. So these three things, that is the linear charge density, surface linear charge density, surface charge density, and volume charge density, these are the important result which we are getting, and these result helps you in solving the numericals. Now, this chapter we have already discussed in the class. Before closing of the schools, we have already discussed all the things about this chapter. Only these small topics are left, so we have discussed it today. Now coming to the homework part, coming to the question answers. So I have set up two questions. So what you have to do in these two questions, first question is, what is the dimension formula of 1 upon 4 pi epsilon 0? You have to find out the dimension of this. And then second, write Coulomb's law in vector form. These are the small questions, so no need of describing them, only find out the dimension of this, and then find out the write down the Coulomb's law in a vector form. Coulomb's law we have already done. So this Coulomb's law we have already done. So it helps you. These three formula helps you in solving numericals. Some few more topics are there, so we discuss those topics in the next class. So thank you. Stay home, be safe.